a manner that does not permit the bacterial growth or uh, that causes some certain uh, problems, or maybe certain off grade formation of the product. So it's important that you always try to secure your food with at low temperature, and definitely for that most part in the industry even, and most part of the market even as well, even in transportation even, we have to consider uh, the low temperature providing equipments, like uh, for that most of the time we utilize vapor compression refrigeration cycles for removing the certain amount of the heat from the products, and vent it out into the atmosphere. So these are the basic introduction about the freezing process and its importance, and definitely in the market or in the industry, uh, variety of the refrigeration cycles are used, but most of them are actually vapor compression cycle. So there are other method as well of like vacuum absorption chiller is also available in the market to lower your product temperature, but most in the industry we widely use the vapor compression cycle because of its dominancy in because you can secure your product up to -10 or even sometimes lower than -10 degrees centigrade, but for vacuum absorption chiller you can't be secure your product below to that mark. Vacuum absorption chiller is widely used where you are need to uh, I mean uh, cool down your stream or product, or maybe the raw material, up to or with a range of 0 to 4 degrees centigrade. For that it will quite suitable, but definitely it also depends upon the environment as well, like if you are utilizing it at very hot conditions like in Karachi, so it might does not work so efficiently at summer duration. Okay, then we have very three basic groups of freezers. Okay, again this is the aspects of the classification. At the beginning I've tell you a different classification aspects, and all these are based on vapor compression cycles, and there are subs classification of the freezer on vapor compression cycles. So one is air blast freezers, direct contact freezer, and indirect contact freezer. So air blast freezers are as shown here in the figure, that there is a large room present to secure or store your product, or maybe the raw material, to a low temperature, and definitely the complete refrigeration cycle in fact is attached with this complete unit. And with that there is a fans available, which can rotate the air with a high flow rate, so that's why they so called as the air blast freezers. On the other hand, if we talk about the direct contact freezers, are the freezers in which we secure our product between certain contact solid boundaries, which are directly coming in the contact with the your product. So in our equipment, we also utilizing the direct contact freezer, and we definitely can easily study the behavior of the products and maybe the raw material if we secure it by using direct contact freezers, that how efficiently it will remove the heat from your product or your raw material, whatever the material is required to be secure with low temperature. One of the most important factor again is that contact direct contact freezers are can be utilized in order to secure your product even lower than minus 10 degrees centigrade. Here in our lab, the unit can lower the material products up to minus 35 degrees centigrade, which is very low temperature in fact. So that's why they are quite efficient, but definitely they require a huge time duration as well for lowering the temperature up to that much extent. Then we have indirect contact freezer, which are normally used in our homes or in the shops as well, so I don't want to explain it very deep manner. Okay, now just the introduction about the computer control contact plate freezer, which we are utilizing in our lab in order to do certain practicals related to the dairy processing. So here this complete unit is completely automatic and computer controlled, similarly as we have studied in the spray drying unit. So in fact in this unit we can reduce the temperature of any body up to even lower than minus 35 degrees centigrade. And a part of that you can also calculate the thermodynamic processing calculation as well, like you can vary the flow rate of the air present for condensation, and you can assess the freezing rate, and a part of that you can also calculate that how the temperature lowers from position to position within the product at various part. So it's a very good unit, and again it's completely computer controlled, and a part of that it's SCADA based as well. So all the data is stored in your computer and you can analyze after that. Now we will talk about the main component of contact plate freezer. So the one is, you can see here, it is present here in fact. So we only discuss, okay, the two is present here. These are actually the condenser, okay, which is attached with the fan, okay, and you can see these are the copper tubes in which the refrigerant move in fact and enter in the condenser in vapor form, and it is supposed to condense in that condenser. Then we have 5, okay, which is present here, and 5 is nothing, it's a filter to prevent the impurity inside the expansion valve. So main the purpose of the filter is definitely when the refrigerant move around time to time. Definitely you can say this boundary layers, like the solid boundary of the copper or maybe the pipeline. So after a period of 1 year or 5 year or 10 years, definitely there certain particles start to erode out from that surface and may move with the refrigerant, which is moving in certain part in the gaseous phase, or maybe in certain parts moving in the liquid form. So definitely at certain parts it is required to install or filter that refrigerant. Okay, so that ensure your is chalking up on various part of this contact plate freezer. So it's just to for prevention base. Then we have 6, you can see here pointed at this part, and it is a side glass to check the refrigerant. It's not quite visible from this angle. Later on I will describe you in detail. Then we have 7 is actually thermal expansion valve, where the main pressure drop will occur from higher pressure to lower pressure. After 7, 8 is actually contact plate freezer evaporator. So here between both these plates you are supposed to place your material, which is required to be cooled down with lower temperature. So it is all the refrigeration cycle cooling out that product, and in response of that the refrigerant evaporate at this part. So that's why it is so called as the evaporator. Then we have 10. Okay, the 10 is actually high pressure switch. Later on I will describe you what is the main purpose. This is only for the safety purpose. Okay. The certain part which is not included in the previous diagram we will include here, like 3 is actually variable flow fan. I mean, you can regulate its RPM, and in response of regulating the RPM, the air that flows through this condenser and condense out. I mean, actually the air exchange its energy with the refrigerant. Okay, and cool down the refrigerant and condense the refrigerant as well. So if this flow rate is reduced or increased, definitely that directly impact the condensation process of the refrigerant. So it is attached actually with the VFD, and you can vary its flow rate as well in regulating its speed from 0 to 100% in that manner. You should know about the VFD, actually variable flow device, which is installed in various parts, and through which we can regulate the flow rate of the liquid, even as well when it is attached with the pump, or when it is attached with the blower or fan like this. It can also be used in order to regulate the flow rate of the air as well. So number 1, you can see here, this is a compressor, which is normally you have seen in your fridge or freezer. So it's a very low capacity compressor, and it's Halmatic type compressor actually. Then we have 8 is again contact plate plates in between. These are the two handles through which you can move up this plate, the upper plate, and in that manner you have to place your material between these plates, and then you just push back that one onto its original position. After that we have four. The four is nothing, it's just a storage tank for the refrigerants. That certain quantity of the refrigerant will accumulate in complete cycle here. So it's just an accumulation tank. Then we have 11. Okay, 9. The 9 is liquid separator to prevent liquid refrigerant from entering the compressor. Actually, if the liquid part enter into the compressor, it causes certain disorderness in the compressor, which is so called as the surging phenomena. So please go through the surging process as well, that it's cause certain hammering formation in the compressor as well, and a part of that it reduces the flow rate of the compressor as well. So if you know the cavitation phenomena which has happened in the pumps due to the presence of the vapor or the gaseous phase in the pump when it is totally confined with the liquid. So similar method here, if the liquid part entered enter to the gaseous part, so definitely it causes certain hammering formation and the disorderness of the process, which is normally known as the surging phenomena. So avoiding that, this separator is installed that ensure that the liquid retain its bottom position and the gas will move on and enter in the suction of the compressor. Then we have 11. The 11 is instrument and measurement elements, like these are the gauges, which is also attached with the temperature sensors here. As you can see in this diagram, this is the temperature transmitter here. The temperature transmitter is also installed here. These gauges also representing the pressure as well, and in response of that they are representing the temperature as well. So you can read them in that manner. They will provide you the both reading of the temperature and the pressure simultaneously at the same time, at the same point. So these are the main component which is very important to understand its complete cycle and its working phenomena. So here is this complete cycle in a more simpler manner, that this is the condenser, the refrigerant get condensed, then it's moved towards the accumulator tank. Okay, and after that we have a filter, okay, that ensured all the dust particles or the impurities removed from this from the refrigerant. Then is move on to a side glass through which you can easily watch the liquid particle or liquid refrigerant moving in forward direction, which you will see in the experiment as well. After that it will enter to the expansion valve, okay, the throttling valve, and after that it will enter to the evaporator, where the liquid phase completely converted into the gaseous phase. Then these gases or vapors move towards this liquid separator, which ensure that the only gas particle will move on in the suction line of the compressor. So in between of that you can see this is the LP low pressure line, and this is the high pressure line. The low pressure line is at the suction part of the compressor, although the high pressure line is at the discharge part of the compressor. So here ST2 is installed, okay, the temperature transmitter, which you will give you the input readings in the computer. On the other hand, the high pressure reading you can easily get with ST1 temperature. So, okay, here AP1 is actually the pressure switch. Okay, the maximum pressure we will allow here won't be exceed from 260 psi. Okay, so if your process run in a manner that the discharge pressure becomes greater than 250 psi, so it's ultimately completely shut down this complete unit, like condenser, fan, compressor immediately. And definitely once the compressor turned off, all the gas will come in the stationary position, because this compressor is only the equipment which is responsible for rotating the refrigerant around this complete cycle. So this is the complete cycle, and then we have these specifications, like here the gas we are using in this refrigeration cycle are R404A, okay, and these are the capacity of the storage tank, the flow rate of the fan maximum when you run the fan at 100% RPM, thermal expansion valve, the plates dimensions, and liquid separators, and so far what we have studied in a very specific manner. Their numeric values actually is represented here. These are the main thermodynamic cycle. Actually, when we talk about a refrigeration cycle, there are two basic diagrams we have to see. One is the TS diagram, and the second is PH diagram. So if we talk about the TS diagram, why it is very important, if you see here, this is your operation line. Okay, after that evaporator, the refrigerant actually enter into the compressor, where the work is done on the system, okay, by compressing the refrigerant. So when it's entered to the compressor, it's definitely in a complete gaseous state. So as we know that the compression or the compressor process is actually constant entropy process, is adiabatic process. So it will move in that manner that it will increase the temperature. Ultimately the entropy of the process remains constant throughout to the point 2. So here the temperature is quite higher, and you can also see it's move up to 60 degrees centigrade at this part when we run this unit. Okay, so after that the discharge of the compressor will enter to the condenser, where it comes in the contact with the atmospheric air, which is almost at in hot and summer conditions around 35 to 40 degrees centigrade. Although, as I have told you, that the discharge temperature of the compressor is around 60 to 65 degrees Celsius. Okay, so when they both come in the contact in the condenser, so it's lowers its temperature to 40 degrees centigrade, and then the condensation begin in such a manner that completely the condenser completely condense all the vapor present or enter into the condenser. So here the heat is removed from the process to the atmosphere. So again, after that, we have the refrigerant, the liquid refrigerant is enter into the expansion valve, and the expansion valve is actually the constant enthalpy process. So here you can see in this diagram, the enthalpy remains constant at this part. So entropy certainly increases, and you can see this diagram is clearly showing how much increment you will get when you increase your entropy. Okay, so when it's enter at point 4, this is the discharge of the expansion valve, and here it will enter into your evaporator, or you may say that your both contact plates, in which in between you have placed your product, which is required to be cooled down at the desired lower temperature. So here it will gain the energy from your product. Okay, it will be at around minus 35 degrees centigrade. Here the expansion valve lowers the temperature from 35 degrees centigrade to minus 35 degrees centigrade. So it's important to note. Okay, and here it will definitely get the energy, and in response of that, the liquid refrigerant start to evaporate and become in the vapor form. So this cycle becomes complete in that manner, and it will continue to rotate in that in the similar procedure. So these are the actual values of R134A which we are using in this unit. Okay, so you can see here clearly at minus 35 degrees centigrade, you have a pressure of around 30 psi, and which is around 140 kilopascal. Okay, so this is the line which is representing that, and after that we have a constant entropy process. So it will increase the pressure of the compressor will increase the pressure from 140 kilopascal to 2000 kilopascal, or maybe 1600 kilopascal. So in that manner it will increase its pressure. Then you have to follow the similar pattern in order to know actual values of the Q, the W, the Q here, when you can easily read out these complete table, graph. So here again, this is a very simple example, as we know that this is a pH diagram, and the pressure at evaporator and condenser remains constant, and the pressure and enthalpy definitely both increases in the compression cycle. On the other hand, the expansion valve is the process, or expansion of gas is constant enthalpy process. So what we comes to know here from this diagram, this is a isothermal process, because the evaporator is actually the isothermal process, because temperature does not changes at all from initial to final position across this process. On the other hand, if we see the evaporator in this diagram as well, the pressure and enthalpy, so again we can also say that it is the evaporator is also constant pressure process as well. Then from this diagram we can see clearly that the adiabatic process is constant entropy process. On the other hand, in condensation or in condenser, Actually, it's not a isothermal process, because there is a certain part at which the sensible heat transfer is also took place. On the other hand, from lowering the temperature of the vapor of the refrigerant from point 2 to this point. Okay, so after that, this is the latent heat transfer will occur, and I mean, it's completely converted into the liquid form. So it's not an isothermal process, although it's a constant pressure process. And expansion valve is again isoenthalpic process. Experimental video first. So first of all, we will run our software. Okay, here you can see clearly the diagram of our TPPC, and this is the software which has the same layout what we have in our SSPC. So here the important parameters are ST1, ST2, okay, which are present at the discharge and suction line. Okay, then ST3, ST4, ST5, ST6, ST7 and ST8. Okay, all are these, you can place them in different position of your products. Okay, and in fact ST8 is ST1, you can see at the discharge of the compressor. Here this is at the suction of the products, and ST8 actually is attached with the contact plate. Okay, and it will provide you the temperature at the evaporator. I mean, at which temperature the evaporation is going on. Now we run our process. So you can see it's asking about how to save the data. These are all the temperature transmitters. Okay, you can place at various part of your product. So we will save our data here first, and okay, saving my, now you can see I have placed this milk in between of that. Now I am selecting the temperature T1 and T2 on graph 1. On the other hand, T3, T4 and all other temperature transmitters are attached. I mean, I place in graph 2. So this is the compressor actuator, and this is, as I have told you, the fan of the condenser. So always remember that this the beginning step of running your refrigeration cycle is, first step is definitely you have to place your material at the plate, okay, at the evaporator, and then you have to run first the condenser. Then after sometimes, and you have to wait for 5 to 10 minutes, then you may run your compressor. Okay, so as I have told you, this is a very long duration process, but you can see clearly there is a deflection start. The red color is actually is a temperature ST1, and ST1 is gradually increasing. On the other hand, ST2 is gradually decreasing. ST1 is the temperature of the refrigerant present at the discharge line of the compressor, so which is continuously increasing, and it will sustain at certain level. Here you can see these temperatures are start to reducing their values. Okay, as when I went to the laboratory, actually that day was a very hot day, so always remember the refrigeration cycle won't effective very much as at a very high environmental temperature, that is on a hot and summer condition. So because it's definitely depends upon your condensation temperature, and when your condensation temperature is higher, I mean the environmental air available for you to condense the refrigerant is that air is at 40 degrees centigrade, so it is required to develop more pressure by the compressor, at 30 degrees centigrade the condensation may occur at 1600 kilopascal, but if you have environmental temperature of 40 degrees centigrade, so for that the compressor need to compress the refrigerant up to 2000 kilopascal. So that is a remarkable increment just because of the environmental temperature. So that's why in a hot condition as nowadays, the refrigeration cycle won't work so effectively, so we have to wait. And you can see this ST1 is now approaching to 50 degrees centigrade near to, okay, and ST2 is sustaining a temperature of 30.5 degrees centigrade, and ST2 is actually the suction line temperature of the compressor. So it is continuously increasing. Actually, I also have represent certain readings of these gauges present here, low pressure and high pressure line. So like you can see they both are present. See this clearly. Okay, this is the reading represented by this gauge, and you can see this is PSI scale here at the inner part, and the temperature scale is also present at the outer part, and you can see clearly it is representing in that manner. So as you can see from this is a low pressure line, and at this level we have a pressure of around 73 psi, or if we see the temperature, which is almost near to the 0 degree centigrade, a bit higher than, but both can be measured by using this gauge. This is a temperature transmitter which is displaying the reading on your screen. This is actually the HP pressure. This is LP gauge. This is SP gauge, and you can see the pressure here is in PSI, in fact, here, okay, and which is approximately near to 180 psi. So it's a beginning part. We have to wait for a while. Okay, we have run this unit for a particular duration, and its temperatures are set up with certain extent. You can see now we move forward and check the low pressure and high pressure readings. See here, it's coming blur. Now as you can see here, the pressure at PSI, which is coming near to 25 psi, okay, and the temperature here is in between of minus 20 to minus 30 degrees centigrade, so which is quite low. And let's see, This is L, low pressure gauge, okay, and this is the high pressure gauge conditions, which is approximately 230 psi pressure, and its temperature is around 60 degrees centigrade, like that. You can see our 134A is placed at black line, okay, or if we utilize our 404A, so for that we have this green line, but in this refrigeration cycle we have our 134A actually. So you can see which is right now the temperature of the line is around 60. Apart of that, I have said you that the side glass is available, through which you can clearly see certain liquid is moving in this line, which is not quite visible, but you can see slightly is appearing that certain liquid is moving in a certain direction. So this is making sure that your condenser is properly working, okay. So this is the complete procedure, and in response of that we have gathered certain readings. So let's move forward to our observation section. So we have placed 3 different products and run our unit, and you can see clearly the time I have taken certain part of our running time. As you can see, this is a very long run in order to gain these temperatures. So ST1 is actually the temperature of the discharge line of the refrigeration of the compressor, although ST2 is on the suction line. So you can see here. Then we have ST3 at the beginning is definitely has 29 to 30 degrees centigrade, but after a certain time period, 1800 second like time, we have minus 0.53. This temperature sustained for a longer period, you can see clearly. Then we have ST4, ST5, ST6, ST7. All these temperatures are installed in various point of the product, okay. Some are on the upper part and some are in the bottom part, so moreover are quite similar. So you can clearly say that both behavior are all behavior are very much homogenized manner. Then AV1 position, definitely this is the fan speed, which we ran most of the time with the 100 rpm 100% rpm. AP1 was completely, it is the pressure switch completely on throughout the process. This is the compressor which we ran our during our process and turn off after certain time period. So you can see clearly the temperature regained its initial position. From doing that practical, we come up with these observation that milk has a freezing point of 0.54, although the cream has a freezing point of 2.95 and butter has a freezing point of 0.2, because when the evaporator reached this temperature, it sustained its temperature for a very longer run. So where at that complete duration only latent heat transfer is going on and the liquid part is converting into the solid phase. So we can say that which is the freezing point of these respective products. So this is the first practical and its results.